Good day, my dear panelists. This is Marcel, and I hope everyone's doing fine. I'm here to present some updates regarding my MSCC thesis. Over the past few weeks, I've been playing around my data, trying to explore some special test cases for the grade requirement of A minus. My goal for this specific study is to test for individual accuracy levels of some appliances with similar power ratings or real power in watts, as suggested by, of course, the panel during my thesis defense. Here, we would want to see if the appliance recognition algorithm is smart enough to recognize individual appliances, even if the power ratings are similar. For this one, the confusion matrices are not representative of each appliance because it measures, if I may say, the global accuracy of each test protocol as I have studied in my experiments and not the appliances itself. And as I have mentioned here, though we have previously used confusion matrices in our recognition experiments, it only computes for the accuracy of the appliance category, for example, with the 5 different types of appliances each, relative to the global training set, and not each individual appliance with respect to the other appliances and not to the one within the similar category. So for the first test case, we use or we will be comparing an Apple iPhone 5s with a Carry 5-watt light bulb. Both has a similar power rating of 5 watts. We get this from the dataset as we have collected it previously, and here we can see that for the Apple iPhone, it has the following average consumption and maximum power consumption also, and as so is the light bulb as presented. So running the test set through the KNN recognition algorithm where k is equal to 10 using the intersection test protocol for 1 data per second, we see that the iPhone was recognized with a rating of 99.91%, and there's a 0.09% confusion with the desktop, while the Carry light bulb was 100% accurately recognized. So thus, in the first test case, we can say that even both appliances has a power rating of 5 watts. Categories are not mutually exclusive, meaning it doesn't mean that the iPhone 5s will be confused with any light bulbs in general or vice versa. So from the example, we can see, or we were able to see, that the iPhone was confused with the desktop and not the light bulb. To highlight this point better, we now move to our second test case where we compare an Apple iPhone 5s with a GE light bulb, which is also 5 watts. So again, both appliances or devices have a power rating of 5 watts. And here are some useful data for both devices. Running it again to the same recognition algorithm. So as is, the Apple iPhone was recognized 99.91% as a phone and 0.09 as a desktop, while interestingly, the GE light bulb was recognized 41.34% only as a light bulb and differently confused with the other appliances as follows: 39.26% as a desktop, 19.07% as a phone, 0.06 as TV, and 0.03 as an electric fan. So carrying the logic from our first test case, this case highlights the possibility of multiple confusions with other appliances. So that we saw that with the GE light bulb 5 watts. It was confused with 4 other categories and not exclusively confused with a phone. Lastly, we study our last test case, which compares the Apple iMac desktop, MacBook Pro laptop, and a Camel electric fan, stand fan. All three has a similar plus minus 50 watts power rating. So here are some useful information we got from the data set. So as for the accuracies, here we see that the Apple iMac was recognized 99.97% as a desktop and 0.03% as a microwave. As for the MacBook Pro, it was recognized 99.64% as a laptop and 0.36% as a desktop. Lastly, the camel stand fan was recognized 99.97% as a fan and 0.03 confusion as a microwave. This last test case was just a reiteration of the points presented in the first two test cases. So here all three devices were properly recognized even though they share plus minus 50 watts power rating. As a summary, the study explored three special test cases to clarify if the appliance recognition system can properly recognize devices of similar power ratings. From here, we were able to see that categories are not mutually exclusive for appliances with, of course, similar power ratings. Thus, it does not guarantee one-to-one category confusion. In addition, we can deduce that the power rating alone, not with the other characteristics, is not enough to either recognize or confuse appliances from a specific category. This represents then AGILASx as a strong dataset having a raw appliance signature of 6 different characteristics and an experimental signature vector after running it through pre-processing delta coefficient and delta coefficient, having 18 values used for this accuracy calculation. Thank you very much. And I hope these results satisfy the suggestions you were able to give me as a task after my thesis defense. And yeah, that's it. Thanks again. See you soon and enjoy the holidays. Thank you.